All right, let's do a problem on income substitution effects. So as with all of these problems, I'm going to be explaining how I'm parsing the question and what decisions I'm making as I go about trying to solve the problem. So let's get to it here. All right. So we've got Eunice splits her time on the weekend between baking bread and playing games. Her utility function is given by u of b and g, is b to the 1/2 times g, where b is the loaves of bread she consumes and g is the hours of games she plays. It takes Eunice 2 hours to bake a loaf of bread. All right, before I get to anything here, before I start reading question A, I want to realize that we're talking about time here. We're not talking about dollars, right? So when I'm thinking about prices, when I'm thinking about income, we're thinking about time. We're thinking about hours, right? And I've already been given some information about prices here. So I've been told it takes 2 hours to bake a loaf of bread. So I'm going to go ahead and take a note that the price of a loaf of bread is 2, that 2 hours. I've actually been told the price of games as well. So G is measuring the hours of games she plays. So 1 more hour of games, well, the price of that in terms of time is just 1, right? It's that 1 hour. And so I'm going to keep track of PG is just 1. And so we haven't been told anything about how much time she has, so we don't know anything about income yet. But writing down those prices like that, that's going to be a lot easier for me to reference that later on in the problem than going back and trying to reread and parse out that information again. All right, now let's get to part A here. Are Eunice's preferences monotonic? All right, so monotonic, meaning more is better. Well, if more is better, margin utility should be positive. So let's go ahead and figure out the margin utilities here. So I'm going to start part A by getting the margin utility for B and the margin utility for G. So my margin utility for B is the derivative utility with respect to B. So I look up at my utility function. I'm going to bring down the exponent on B, so I get a 1/2 out front. I'm going to lower that exponent by 1, so it becomes b to the minus 1/2. And then we still have g sticking around, so we just have g. For the margin utility of g, I'm going to look at my utility function, take the derivative with respect to g. The derivative utility with respect to g. So the exponent of g is 1, so that would just be a 1 out front. Nothing changes with my b, and when I lower the exponent by 1, that's g to the 0, so that just disappears, right? So my derivative is just b to the 1/2. Okay, so now I notice that b is positive, g is positive. These are just goods, right? B is positive here, so everything in these is greater than 0, right? And so since margin utilities are greater than 0, more is always better. So preferences are monotonic. Okay, so now we go back up to question A here, and we're also asked, are Eunice's preferences convex? Right, so for convexity, I want to think about the marginal rate of substitution. I want to think about, in particular, is that indifference curve, right? Is it shaped like a convex curve? If it is, then those average bundles would lie above the indifference curve. And marginal rate of substitution is going to tell me that because it's the slope of that curve. So let's go ahead and get our marginal rate of substitution. And let's think in terms of a graph that has B on the horizontal axis and G on the vertical axis. All right. I'm making that little mini graph on the side so that I stay consistent throughout the problem, right? So it's just a little note for me to know that's how I'm doing my orientation, because that's going to matter later on when we talk budget constraints and slope of the budget line and things like that. Okay, if B is on my horizontal axis, my marginal rate of substitution is minus margin utility of that horizontal axis good, which is B, over the margin utility of the vertical axis good, which is G. So we found those margin utilities already. So I'm going to plug in margin utility for B, which is 1/2 b to the minus 1/2 g. And we're going to plug in what we got for the margin utility of g, which is b to the 1/2. And since this is a nice Cobb-Douglas utility function, this is going to simplify. My b to the minus 1/2 is going to combine with this b to the 1/2 and leave me with a b in the denominator, and then I've just got my g in the numerator. Okay. All right. So remember, the reason I found the MRS is we want to think about convexity. Okay. And so now I know as we move down and right, along an indifference curve, and so in parentheses here, I'm going to say it says G is going down and B is going up. The magnitude of the MRS, right, since it's got G over B here, well, G is getting smaller, B is getting bigger, so that's going down, right? So the indifference curve gets flatter, meaning it's convex. All right, notice I used a little bit of shortcuts here, shorthand notation, right? So I abbreviated indifference curve, I used arrows for down and up, right? Abbreviated indifference curve again here. Those are abbreviations that when the professor, me, is grading the exam, I know exactly what those things mean, right? So if I'm going to know what that means, go ahead and use those abbreviations. Save yourself some time on the exam, right? Okay, we're done with part A here. Time to move on to part B. All right, so part B. Suppose that Eunice has 18 hours of free time on the weekend to devote to bread baking and playing games. So that 18 hours right there, this is now telling me my income, right? So I'm going to make a little note of that income is 18. All right, write down a budget equation that captures Eunice's affordable combinations of B and G. Your expression to contain only B, G, and numerical constants. All right, well, we've pretty much done the work for this just by noting what's in the question. So for part B here, our budget equation is basically always going to be the spending on each good, so the price of that good times the quantity of the good, plus the price of the other good times the quantity of that good. So in this case, PB times B plus PG times G. Those have to add up to our income. In this particular case, we look back up, and lo and behold, I don't have to reread the question. I wrote out my prices already, right? So PB is 2, PG is 1. So going back down here, right, we can replace PB with 2, so that's 2B. Replace PG with 1, so it just leaves with just G there. And we made a note that in part B, it told us that income was 18 hours. So there's our 18. So that's all we need to do to get part B. Right? So that's our budget equation in this case. So moving on now to part C. Given your budget constraint from part B, in Eunice's utility function, determine how many loaves of bread Eunice will bake and how many hours she'll spend playing games. You can assume that she has no other use for her time and that will increase her utility. All right, so this is just a standard choice problem, right? She's going to want to find the spot on her budget constraint that gets her the highest possible indifference curve. That's going to be the one that's tangent to her budget constraint. And so to find that point of tangency, we're going to start with that tangency condition. So we're going to set up the slope of our budget constraint being equal to the slope of our indifference curve. And this is where it was useful that I wrote down my little mini graph over here to remember how is setting things up. Got B on the horizontal, G on the vertical. So the slope of my budget line is going to be the price of that horizontal good over the price of the vertical good, right? Or at least that's the magnitude of the slope. And then the slope for my indifference curve is that margin utility of the horizontal good over the margin utility of the vertical good. Now we already figured that out in the previous part, right? That was that 1/2 G over B. All right, so what I'm trying to do now is I'm trying to get one good by itself so I can plug that into the budget constraint and solve for the other one. I've got G in the top over here, so what looks easiest to me is let's move this 2B over with the prices, okay? So that is going to give me that G is equal to 2 PB over PG times B, all right? So now that's as far as I can get with our tendency condition. All right, one good in terms of the other one and something to do with prices there. So to solve for an exact value, or to solve for it in terms of just prices and income, right, we would need to plug into the budget constraint now. So if I look over here from part B, we already asked for the budget constraint. But I don't want to use what I answered part B with, all right? And the reason for that is that I know I've still got part D and E to go here, right? And if I look at them quickly, it's saying something about an income effect, something about a substitution effect. That means prices are going to change, right? If I use 2B plus G here, I don't know how prices entered into that. And I'm going to have to redo everything when I get some new price down the road. If I leave it general, then I can just plug into the very last expression I get when I get a new price if I have to find a new bundle. So that's what I'm going to do. I'm going to take this expression for G and plug it in to that general form of the budget constraint right over here. So we're going to have PB times B plus PG. Now we're replacing G with this expression for G. So that's going to be 2 PB over PG times B. All of that is equal to income. So this PG cancels with this PG. And now I've got PBB plus 2 PBB is equal to I. That's 3 PBB is equal to I, or B is equal to I over 3PB. Okay. All right, so when I look at that expression, that now has B in terms of income and prices. That, if I plug in my income of 18, if I plug in my price of B of 2, that's giving me exact value for B, right? So I'm pretty much there. Before I do that, though, I want to also find a demand equation for G, since I'm going to need to find a value for that as well, right? So I'm going to start on a fresh sheet of paper here, and I'm just going to first transfer over that final bit of information I got, all right? So we've got that B was equal to I over 3PB, right? And I'm just going to box that for myself because that is my final demand equation for B. I'm going to use that later on in the problem, most likely. Okay. To get my expression for G, I'm just going to go back to what I had at the end of the tendency condition. So I've got that G should be equal to 2 PB over PG, all of that times B, but I can plug in this for B. That's going to be I over 3PB. And so this PB cancels with that PB. And so I'm left with 2I over 3PG. So that I'm going to write over here and box it because that's my final demand equation for G. That's how I'm going to get an exact value for G. All right, so let's go back now and remember why we were doing all of this, right? We were doing this to answer question C, which was to figure out exactly how many loaves of bread Eunice was going to bake and exactly how many hours of game she was going to play. So what's the exact value of B, the exact value of G? Now that we have these demand equations, all we have to do is plug in our prices and income into those, which we conveniently wrote off to the side so I don't have to go through and look through all this text to find it anymore. So our B is going to be equal to income of 18 divided by 3 times the price of B of 2. So that's going to be, right, 18 divided by 6. It's going to be 3 loaves of bread. As far as games go, we're going to have 2 times our income of 18 divided by 3 times our price of games, which is 1. So that's going to be 18 divided by 3 is 6 times 2. That's going to be 12. So there is my final answer. 3 loaves of bread, 12 games. All right, so let's go ahead and now tackle part D. All right, part D says Eunice now gets better at baking bread. Each loaf now only takes 1 hour to bake. So right away, I now know that the new price of bread is going to be 1 hour. So I'm just writing that down to keep track of that new piece of information. What is her new optimal consumption bundle of bread, loaves, and hours of game? All right, so since we have our demand equations here, all we have to do is plug in those new values. So I'm going to call this B prime, since it's my new value. We still have our 18 hours, and now it's just 3 times 1, because that's our new price of bread. So that's just going to be 6 loaves. On the game side of things, well, nothing changed because PB didn't enter into that equation. So it's just 2 times 18 divided by 3 times 1, which would be 2 times 6, which is still going to be 12. And so there's my new bundle. All right. So you can see why it helped that we left things generally. All I had to do was just plug into that last step to get this. All right, now we're ready to tackle the final part of the question, part E here. How much of that change in bread loaves was due to the income effect? How much was due to the substitution effect? All right, so what we're trying to figure out is this change due to an income effect, this change due to a substitution effect. So to do that, we need to find this intermediate bundle, right? So that's the bundle that's using the new prices, this new price of bread of 1, but we're going to adjust the income so you can just afford that old bundle, right? Which was 3 loaves of bread and 12 hours of games. So we need to figure out what's this level of income, call it I tilde, that uses the new price of bread, right? PB prime, but gives that original amount of bread, I'll call it B0, and that original amount of games, G0. Right? Well, this is just a matter of plugging in the right numbers here. So the new price of bread is 1. Right? The original loaves of bread was 3. That's what we got in part C. The price of games is still 1. The original number of games was 12. And so 3 plus 12 is going to give me 15. So that would be the income that corresponds to this intermediate bundle. And so the quantities in this intermediate bundle, so I'll call it, for the moment, let's call it just B double prime and G double prime. Okay? We're going to use that $15 and the new price, right? So that would be 5 loaves of bread. For games, so G double prime, right, it's going to be 2 times 15 divided by 3 times 1. It's going to be 30 divided by 3. That's going to be 10. Right? And so now we just have to compare the right bundles. We've got these 3 different bundles. We've got our original bundle of 3 loaves of bread and 12 hours of games, our final bundle of 6 loaves of bread and 12 hours of games, and our intermediate bundle of 5 loaves of bread and 10 hours of games, right? And so what we need then, let's make certain we're doing what we're asked for, is the change in bread loaves due to the income effect and the change in bread loaves due to the substitution effect. So the change in B due to the income effect, right, and the change in B due to the substitution effect. So for the substitution effect, that is going from our intermediate bundle, right, or sorry, from our original bundle to our intermediate. So we're going to do intermediate minus original, okay? So that's our B double prime minus our original B. So that was 5 minus our original of 3, that's 2. Okay. For our income effect, that's then going from our intermediate, right, to our final bundle. And so that is going from B double prime to B prime. So B prime was our 6. B double prime was our 5. So that's a change of 1. So due to the substitution effect, we ended up baking 2 more loaves of bread because bread looks relatively cheaper, right? It takes less time compared to gaming than it did before. And because of the income effect, we're also consuming less, or we're baking more bread because our time goes further now because bread is cheaper, right? So we feel like we have more income. We feel like we have more time. And so there is our final answer to the final part of the question.